Hey, seniors. Another fun week at Gov School, or not at Gov School, huh? Hope you're enjoying the snow. This is week 3 of a bam, bam, bam with natural hazards. Believe it or not, this is all actually perfectly germane to the AP Environmental Science material, even though you're getting some pretty hard geology here. But earthquakes are important, right? I mean, the entire surface environment is affected by them in many, many different ways. Earthquakes form a lot of our landforms and so forth, and are responsible for significant amounts of destruction, tsunamis, all kinds of interesting things that, of course, our ecosystems have to be are adapted to, or have to be adapted to. And so it's important to know something about these. On top of the fact that let's remind ourselves that plate tectonics is what makes life possible on this planet. And so if it wasn't for plate tectonics and the things that cause earthquakes, the processes that lead to that, we wouldn't have any biogeochemical cycling, or at least very little of it, and so the life wouldn't be possible on this planet. So it's really important to remind ourselves of that all the time. Anyway, so here is the Iris Earthquake browser, and for what you're doing this week online, this is I love this thing. I, I've been yearning for a chance to use this with Gov School students for a long time. Actually, I use that all the time at Lord Fairfax, but um, it's a really cool browser, right? And so here, what I've done, if you're looking at the assignment from for this week, which I have here, of course, I'm looking at it myself. Step 2, it's asking you how many events occurred globally on your birthday. I had to do a lot of clicking, but I managed to get all the way back to 1979. Um, my finger was tired by the time I got back there. It's 42 years. Um, so anyway, I was born on January 16th of 1979, and so I'm looking at the earthquakes that occurred on my birthday. I've actually not done this in a long time. It's really interesting to go back and do that. There's some cool things you can do with this, by the way. It's going to have to, every time you move it, it's going to have to load things. What you're going to have to do is you'll have to uncheck the time range thing. This box is automatically checked for the earliest available, okay? And you have to uncheck that, and then you have to alter or change the date. And then you have to click apply. If you don't click apply, nothing's going to happen, okay? Um, just really quickly, a great place to look for what's really interesting about this, one of my favorite things about this is to actually look at places where there's subduction going on and significant young high angle subduction, like what we call with the convergent boundary, right? We're like around here, the west coast of South America. And I'm just going to show you something really cool. I can select this region, right? And once I do that, it'll only select earthquakes within that particular box for the year of my birthday, right? And so it's still selecting 5,000 earthquakes. And you'll see that some of them they have all these different colors. Well, the different colors correspond to the depth of the earthquake. As lithospheric plate material is subducting down beneath the overriding plate, it's not melting, right? I mean, it doesn't do any melting much for the most part until it gets way down in there. And actually, originally before plate tectonics started on this planet, about probably anywhere between a billion and 700 billion years ago, 700 between 700. Let me put it back up a little bit. Between 1 billion and 2 billion years ago, probably modern plate tectonics really got going. And actually, it might have been as late as 700 million. Modern, what we understand is today's plate tectonics, anyway. Before that, the core mantle boundary was different. I mean, we have what we call slab graveyards down there. We can see them using seismic tomography. We can look at a 3D cross section of the Earth's interior, and we can see where these plates are. There's actually 2 levels within the mantle where the plates tend to collect, and they haven't melted, right? So how do we get volcanoes? Well, again, the plate is subducting, and you're actually melting the upper mantle that is above there because now you're introducing water, and water actually lowers the melting point of the upper mantle, causing it to turn into liquid, and then buoyancy brings it upward. Boom! You get volcanoes. As these plates go down, though, you're moving a plate down into solid rock. The mantle is solid rock, right? You got to melt it to make the volcanoes, but the mantle is still solid rock. So you're subducting this lithosphere into solid rock, and that, of course, causes friction, earthquakes. The earthquakes occur at different depths, and of course, depending on the plate boundary, they're going to occur in different ways. So now, all right, so I'm going to move my little video out of the way here, and I want to look at 3D view of this. And if I do that, it's actually, they've updated this, which is kind of cool. I can look at where the earthquakes are occurring as the plate goes down. And here you can see the plate is actually diving down practically at a 90-degree angle into the mantle. But you can see the red earthquakes are the deep ones. Those are the really deep ones with a really deep focus. That's the term we use for that. Yellow is more moderate, green is shallow, and of course the purple ones are the most shallow earthquakes. And there's the most of those, of course. What we might ask, well, which ones are the worst? Well, that's hard to say, except I can say that the size in this case, the size of the object here isn't necessarily indicative of that. All right, but I'm going to go ahead and get out of 3D view. Let's go ahead and deselect this region. And let's look at another region that has a very different type of plate boundary. Let's look at earthquakes along the Mid-Atlantic Ridge. And there's not a lot of those, actually. What we're going to do is select a region here. We'll do the southern Mid-Atlantic Ridge. And we'll just go right along here. Okay. And there'll be a bunch more earthquakes that pop up here, obviously. I've still got it listed at 5,000 earthquake maximum here. So we'll give it a moment to load. And of course, at your house, it's going to, depending on your internet, if we look at the 3D view of this one, you see they're all purple. For the most part, they're all very shallow. The earthquakes are not very deep. And that's because there's no subduction going on here, right? Now you've got some earthquakes over here because I happen to grab some mantle plume material here where you have some stuff moving up from the, there's some islands over there where material is moving up from deeper in the mantle vertically, and that's a plume. If we looked at Hawaii, which we can do actually, let's go back. Let's do that. Let's look at Hawaii. Select new region, and we're going to go over Hawaii and see what kind of earthquakes we get over Hawaii. There shouldn't be a whole lot of them, and indeed there aren't. But if we zoom in a bit and we look at Hawaii, you can see the earthquakes. Wow, why are you getting earthquakes at all? There's not even a plate boundary there, right? It's in the middle of the Pacific Plate, but you're getting earthquakes because you're getting liquid mantle material moving its way up through the mantle, deep mantle material from way down here. And by the time it gets up here, it does start to create earthquakes and so forth. So you get earthquakes in all kinds of different locations around the globe, and that's one of the things I wanted to show you here. All right, so I'm gonna deselect the region here. So the questions are basically, how large was the largest event on that day, and where was it? All right, so what you need to do is you may need to change it to say to change the magnitude range to say something like I would say change the minimums here. Were there any nines? There were actually a couple of really big earthquakes that day, the day I was born. If I click on that one, I've got that one there, and I've got in Japan, and I've got one down here in Indonesia, both 9.1s. Those are really big earthquakes. Jeez, it's a good year for earthquakes. I chose 9, not actually expecting to see any earthquakes. And then what if I were to then go ahead and put all values back, and then if I display 5,000 events that are all magnitude 7.5 or larger. Well, let's change this to 7.5, right? And then I apply it. It's actually going to apply automatically. And, the view changes changes a bit, right? There's a lot of places that don't have any earthquakes at all anymore. You can see there's no earthquakes along the west coast of South America. All the earthquakes are, for the most part, around the Pacific Rim, and particularly from the Gulf of Alaska all the way down through Indonesia and into the Philippines and then New Zealand. And so, there's some earthquakes over here on this part of the Pacific Rim. But if you look over here in the Atlantic, there's almost nothing. I mean, it's quiet, right? That's the kind of thing that the assignment is asking you to look at, right? Now, in our state in the past year, so if we go back and look at we go back and uncheck that box, and we hit apply, and then what we could do here with the state thing, because the state is, you see what happens. We have to actually kind of zoom in on the area to be able to get some of these earthquakes to show up. And there may not have been any earthquakes in Virginia for the most part. And now this asks in the past year. So let's look at the latest available here. And bad date used. Let's go ahead and choose February. Let's go with February 1st, and we'll change this to we'll change it to February 1st, 2020, and we hit apply. I know there's been some sort of earthquakes in Virginia, but not apparently enough to register. Well, I've still got the 7.5. Put that at 0. All right, and then we'll see. There are some earthquakes that have shown up here in Virginia. I can make that a little bit bigger and include the Panhandle. And I can adjust this a bit more just to include Virginia. I can have some fun with this, right? So there have been some earthquakes in Virginia, nothing terribly large, right? But anyway, you always have you have to keep hitting that apply button. That's really, really critical because otherwise you're going to be stymied. All right. Now, if we go to these particular URLs, right, what I want you to do is create a frequency magnitude range of earthquakes for each site and the depth distribution. You should listen to the math. We've already talked about the map colors and so forth, what they all mean. And the spatial distribution is just roughly giving an idea of how big the area of earthquakes is. And then we can look at the satellite view for each region and so forth. So let's type in this first one. All right. That's going to be go.gl/8drnb. And I believe that's going to be an O. All right. I should pull this up with a particular set of things highlighted. Indeed, there it is. Okay. So if I'm looking at this location, I'm looking at Japan. I'm specifically looking at the Marianas Trench region. So it's a very important area, deepest part of the oceans over here, and so forth. So if we look at this from various views, of course, you can animate the earthquakes. They had some cool features since I last looked at this. But anyway, just follow from there, right? You're going to do a quick. You might do a quick sketch there, or you might just describe it. That's fine too, because I know you're describing this in a PDF viewer here. What I want you to do is create a table that you can then compare these things to. It's going to be looking at different sites that have different types of plate boundaries. Okay. All right, and then it asks you. I think I included that part. Yep. So you should also be thinking about these other things as well. So you shouldn't have any trouble going through this. All right. In terms of this, looking for whatever else might be challenging here. This is revisiting the egg model from the beginning. When I think about the egg model, think about the egg as a hard-boiled egg. That's probably the best way to think about it, because if you think about the egg as one that's uncooked, it's kind of gooey and messy, and I think it misrepresents the interior a little bit. We do have a liquid layer of the Earth. The outer core is liquid, but the vast majority of the Earth's interior is solid rock. The mantle is solid rock. The inner core is solid rock, and so these things are important. And so if we think about the egg model, think about it as a hard-boiled egg. Of course, you don't really know that, of course, looking at the egg necessarily. There's no way to tell whether it's hard-boiled or not if it's in the fridge. The specific gravity does change, of course, a little bit when you cook the egg, but it's hard to necessarily tell that in your hand. All right. I hope this is helpful, guys. I think particularly with the use of the website, it should be hopefully helpful. I'm going to end this here, but I'll see you all tomorrow, okay? All right.